Greetings and welcome. We're talking about 2010 Necap question number 4. And this is about circles. Back in the day of 2010, our students here, Twin Valley Math students, represent YouTube page, Twin Valley Math. Subscribe. Got 50% of our students get this right, and 44% of the state's students got this right. So yay on us. Woohoo! Right? So it says a circle C has its center at these coordinates. The coordinates of one point on the circle are -1, 6. What are the coordinates of another point on the circle? And now technically there are infinitely many points on our circle, but I'm guessing that only one of the finite ones they gave us will actually work. So let's see if I can draw kind of a picture of this. Let's see, the center is at 3, 8. So that is significantly in kind of the first quadrant. I got to go up quite a ways for that. So let's see. I'm just gonna pretend this is 8, and then 1, 2, 3, and I'll go down 1, 2, 3, 1, 2, 3, something like that. And let's see if I can actually get a circle here. So our circle's center is at over 3 up 8. So there's our center C, right? Circles, by the way, are named by their center point. So circle C, its center point is also labeled C. And then it says the coordinate of one point on the circle is -1 up 6. So let's see, 6 would be 2 less than 8. Oh, they didn't. Oh, what? It's diagonal. I was wondering, there was a chance that what if it happened to be like, one of the points that's kind of like one of the cardinal directions from it, because that would have made things easy for us. However, they didn't. So here's that point. So what is this distance here going to represent for our circle? No? This would be, yeah, a radius. So you could possibly find a point in this direction by another radius. If I actually mirror this point over this line, this would also be on the circle. So I mean, if you imagine our circle kind of looking like this, something like that. Actually, you know what? Let me see. Let me open up my toolbar. Do I have a decent circle tool here that's defined by center and radius? It is. And all right. Bam. Something like that. Aha. What do you know? So our circle looks something like this. So I just want to point out that, right, if I kind of mirrored this point over here at, find out what distance that is, I'd be able to, I don't still want my circle tool. Yikes. Yikes. Let's see, toolbar, go back to it. Here we go. I like my just plain old scribble line there. All right. Problem solved. So yeah, if I mirrored this point over here, I'd be able to, that would be a point on it. If I mirror the point up here, that would be, and that would be. So there's that possibility. I mean, what we could do is actually, the simple solution is maybe plot some of these and see the reasonability of it. So let's see, would -1, 5 work? So -1 up 5 would be right here. That's definitely not going to be on the circle. 0, 0 is definitely not going to be on the circle. Over 5, 1, 2, 3, 4, 5, and up 4 is going to be somewhere like here. I don't think the circle is going to come down that low. We could find out for sure, because if I know this distance, I could actually find this distance is the same one. That's also a radius, same as that distance or that distance, right? Wherever I go on the circle, it's the same radius away. And then I've also got over 6 down 1. Well, maybe this one's the best bet, but let's see what we get. So to verify, let's actually find out what this radius is. How could I find that radius? Distance formula, perfect. So the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And let's plug in what we've got. So I've got 3, 8 is one of my points. So that would be a decent, I guess I'll do -1 minus 3 for x2, x1 squared plus, and then I'll do 6 minus 8 squared right there. So that's going to be our distance. Let's calculate this. Let's see, that's going to be -4 all squared. They might have actually even given us a 3, 4, 5 here. That would be interesting. That'd be a classic Pythagorean case. Maybe they didn't. Right, yeah, -2 squared. This problem is proving to be slightly more difficult than I'd anticipated. Let's see, 16 plus 4, that's going to be the square root of 20. Wow. Which, by the way, I could break into square root of 4 times the square root of 5. So it's 2 square roots of 5 is my radius. All right. So, wow, that actually isn't that helpful yet. Let's see. Over 3, up 8, yep, and then back 1, up 6. All right, yeah. So if this is the square root of 20, which, by the way, the square root of 20 is somewhere between 4 and 5, right? It's square root of 16 would have been 4, square root of 25 would have been 5. This may actually require all of the skills from today's lesson in order to do this a little bit better. Over 5, up 4. Wow. You think it's this one?
No,
The 5, 4? I mean, it could be. Obviously, my graph isn't to scale.
because you can see that it's 6 and then 5 and then this 4 is right under.
That's true. I can actually do a bit of like a rise over run between these points, which might be the easier way before I actually get into an all-out equation of a circle thing. So let's see. This is 2 and this is 4 over. So the question is, could I go down 4 and over 2? And that would still have the same hypotenuse for that triangle, right? That'd still have a square root of 20 hypotenuse. So let's see, is going down 4 from 8, that would land me not on 5. Oh, wait, sorry, on 4, yeah. And then over 2 from 3, yeah, that appears to work, right? So if I have 3, 8, and if I went, let's see, what did I say, down 4 and plus 2, I would get 5, 4. So yeah, so that's actually one way to verify it for sure. So 5, 4 definitely happened to be further up here according to scale. Bam, so 5, 4 works. And if my graph was to scale, it actually would have worked easier. Now, there is technically, if you know the equation of a circle, which we're going to talk about today, the equation of a circle is actually related to the distance formula a lot. The equation of a circle is actually this: r squared equals x minus h squared plus y minus k squared. You don't have to write this down now. We're going to hit this later in today's lesson. And so, for instance, I know that my r is the square root of 20. I know that my x would be whatever my x coordinate of any particular point is. My h is going to be the x coordinate of the center, so that'd be 3. And my k is the y coordinate of the center, so that would actually be 8. So what I could actually do here, square root of 20 squared, you can see is going to be 20. X minus 3 squared plus y minus 8 squared, all squared, right? I could actually have plugged in combinations of x and y until I saw which one worked. It's not as friendly of a way, but let's actually check 5, 4. So is 20 equal to 5 minus 3 squared plus 4 minus 8 squared? And I believe it is, because that's going to be 2 squared plus -4 squared. And oh yeah. So that's 4 plus 16 equals 20, and 20 equals 20. So that verifies that it is in fact a point on our circle algebraically. But yeah, I kind of think that this little right triangle trick is probably the easiest approach. Or if your graph was just to scale enough, you might have been able to spot it right off the bat. And this was really the only reasonable point that I had to guess from. I knew it couldn't have been this one because this one would have been just too far away. So you could have possibly somewhat confidently guessed on this after drawing your sketch, and you would have been able to get it. So anyway, so thanks for watching, internet friends. I hope you had a great time. Bye.